Hello everyone, welcome to this video. So in this today's video, we'll be solving the problem flow in BST. So as you can see, it's a medium level tag problem, but to be honest, it's not really medium level. It's a very simple question. And this is the problem of the day for today on Geeks for Geeks. And what are the companies that has not been given? So we have no idea what companies have actually asked this question. So let us first understand the question. You are given a BST, binary search tree, with n number of nodes and value x. And your task is to find the greatest value node of the BST, which is smaller than or equal to x. All right. And note, there's a note given when x is smaller than the smallest node of BST, then return -1. That's it. So this is the question. So we'll understand what is BST and what are they actually trying to ask with the on notepad. So this is the sample test case one. Before that, we'll understand what is a binary search tree. So let us assume this is the tree that I am actually taking: A, B, C, D, E, F, G. All right. So this is the tree that I'm taking, and I'm saying that this is a BST. So what is the condition for this to be a balanced search tree? So the condition for this to be balanced search tree is all the values. Let us assume I'm standing on this position. All right. I'm standing on this position. And for this to be a binary search tree in regards to A, I need to have B, D, E. So B, D, E, these are all the values. Okay, B, D are the values or the data that is present in that particular node, should be less than A. Okay, should be less than A. And this particular node, so let me color this with different color. Um, okay, this everything is gone. This is B, this is D, this is E. Okay, so this is, let me indicate this with fine. So this thing, and all this to the right, CFG and CFG. So CFG must be greater than A. So this is for in regards with A. Now what about if we are on B? All right, if we are on B, then D, all values to the left of B. So this one, so this D should be less than B, and to the right of B, so that is E. So E should be greater than B. And what about when you're standing on C? So when you're standing on C, everything to the left of C, that is F. Okay, that must be less than C, and everything to the right of C, that is G. So G must be greater than C. So that's it. So this is the primary condition of, this is the only condition of a tree to be a binary search tree. So all these conditions must be met. So what are these conditions? This condition, this condition, this condition, this condition. So this condition, this condition. Okay, this is the explanation regarding a binary search tree. So we have understood what is a binary search tree. And what are they actually asking? They're asking is, your task is to find the greatest value of the node of the BST which is smaller than or equal to x. So there is a x value given. So we can take this particular example itself. There is an x value given, and we need to return that particular value which is less than or equal to 87. Anything, it's fine. And maximum. So if there are set of values, n set of values which are less than less than or equal to 87, then I'll be taking the maximum value, that is like 87 itself, because I need to have the maximum value from this set. That's what they're asking. They're asking is to greatest value of the node of the BST which is smaller than or equal to x. All right. So I need to have if it target is 87, then my answers could be from where's the data set starting from 1. So node data can go from 1. So it can start from 1 till 87. So I'll be, if I find 87, then I'll be returning 87. If I find 86, so like this is the data set, right? So anything 1, 2, 3, so on till 87. So if I find 87, then I'll be returning 87. If not, if I find 86, then I'll be returning 86. If not 85, it's what I found the maximum thing, then I'll be returning the 85. So this is the condition. This is the thing they are asking. So why am I going in much into deep regarding all these things? Because with this clarity, you can easily code the question in just 4-5 lines. All right. So you need not do some other things, techniques, just the simple recursion if you understand this basic stuff. All right. So That is what the question is. So you need to find the maximum value. So because it's 87 they're asking, we have 87 in our tree, so we'll be returning 87. Let us assume this is not 87. Okay, let us assume this is not 87. Let us assume this is 86. Okay, 86. In that case as well, because there is no 87, the only node that is less than 87 and maximum is 86, so we'll be returning this. This is the maximum value of the node that is less than 87. So we have this, we have this, we have this, we have this. There are total 5 values that are less than 87, but we need to return the maximum among them. So 86 is maximum among them, so this is what we are returning it. Okay, so this is what we are returning. So this is a very basic question. So what must be the technique? We have understood what is a binary search tree. So this is a BST. We have understood what is the BST. We have understood what are they actually trying to ask in the question. Now, how do we formulate this? Okay, so that is the question. So this is the code. Let us not see the code first. We'll understand what is our primary, approach to solve this question. So there are only two cases. Let us assume X is the target that's been given. Okay, so there are only two cases. One case is when your root data, the present root data that you're standing in, its data is less than X. Second case, the root data is greater than or equal to X. All right, so these are the only two conditions. Like okay, let me write this properly: greater than X or less than or equal to X and greater than X. So why am I doing this? I'll explain you, not to worry. So X is the case, and root data, the present root that you're standing on, its data can be less than or equal to X, or its data can be greater than X. If its data is greater than X, then our primary intuition is to go to the left side, right? Go to the left side, go to left of root. Why is it so? Because we have understood what is the go to the left of root. Okay, go to left of root. We have understood why should we go to the left, because in binary search tree all the values to the left would be less than A, all the values to the right of A would be greater than A. All right, so that is the condition of a BST. So when we have found that particular root data, the root on which we are standing, its data is greater than X, then we'll go to the left of root. Okay, we'll go to the left of root, and then we'll again do the analysis. So what analysis is that? That is the recursion. We'll be leaving it to the recursion. All right, so particular thing that we are doing here, the same thing will be repeating the analysis here as well. What if the root data is less than or equal to X? All right, the particular root data is less than or equal to X. So if that is the case, then I'll be going to my right. Okay, then I'll be going to my right, go to right and check, go to right of root and check if there is any other value in the right side of my root which is still less than or equal to X. That's what I'll try. So I'll go to the right and check if there is any value, that is less than or equal to X. All right, so that is what I'll be checking. So let me give a classic example to this question. So this is 1, this is 2, this is 3, this is 4, and sorry, why am I doing this? So it's a binary search tree, right? So let us assume this is 10 and this is 9, and okay, let me give this some gap, or maybe 7, and here 14, and to this left of 7 we have 6, and to the right of 7 we have 8, and to the left of 14 we have 11, to the right of 14 we have 15. Okay, now I'm trying to find the 15. Okay, I'm trying to find X equal to 15. I'm trying to find X is equal to 15. And now when I'm on this particular point, 10 can be my answer, because 10 is less than 15, right? 10 is less than 15. So 10 can be my answer. So what is the thing is, I'll be storing this particular value in my answers. Like present answer is 10. Present answer is 10. Present till now, I can assume that 10 can be my answer. 10 can be my final answer. Now I'll be going to my right. And check, because all the values to the right will be greater than 10, and because our target is 15 which is greater than 10, so we need to look for searching on to the right. So I'll be going to the right and I'll be checking if I find any value to my right which is still less than or equal to 15, then I'll be taking that value, because all the values to the right will be greater than 10. So all those things can be my can be a potential thing for my answer. So I'll be going to the right. Now I'll be on this. I'm on 14, I can now assume that my present answer is 14. So far, I can say that 14 is the only answer that I've got. Now, still it is less than 15. So I'll be going to the right. Now I'll see that 15. Yes, this is the value that I'm looking for. Yes, so I'll be taking my present value as 15 and I'll go to the right. There is nothing to the right. So I'll return. There is nothing to the left. So I'll return. So when I find that, I found this answer. This is the maximum value that I can find. Maximum value that I can, that I can consider. That I can consider. Okay, that I can consider, because my target is 15. My target is 15. I cannot go beyond 15. I can only take the values that are less than or equal to 15. So I can take 10, I can take 14, I can take 15. After this, I need to find the maximum value. So 15 is the maximum value that I can take. So that would be my answer. So that is the thing that we are doing. So let us go through the code now. So int temp is what we'll be checking for the left and right. All right, so this is the base condition. So base condition is if root equal to null, then return -1. All right, so we have not found anything, so we'll be returning -1. Int temp present is int min. Like this is the present value, present answer that I'm assuming. So if root data is greater than x, if root data, that particular data or root that we are standing, if it's greater than the target, that means we need to go to the left. We need to go to the left, right? This is the thing. So if the particular root data is greater than x, then we need to go to the left. If it's greater than x, then we'll be going on to search with the left side of the root. That is the reason temp is equal to floor root of left and x. Else if root data is less than or equal to x, then my present answer can be root data. Okay, my present answer can be root data, data, and I'll be checking for the right side of root. If I find a much better answer than the present answer, so I'll be going to the temp and I'll be doing floor of root of right comma x, and I'll be returning the maximum among the present and temp. So whatever the answer that I found in the temp to the right of my right of the root, I'll be taking the maximum of present and temp. Let us assume I've not found anything. All right, I've not found anything to the temp, so that means temp would be -1. So in that case, maximum of present and maximum, and present is int min. Let us assume our int min is like we have not anything to our present found anything in related to this also, like even if it's not going in this else if also, it's just gone to the first if. In that case, my present would be int min and temp would be -1. In that case, maximum of this would be -1. That would be returning. That's what he's asking the question as well. If you do not find anything, when x is the smaller than the smallest node of BST, then return -1. All right, so if this is the BST, okay, let us assume this is the BST. This is 10. Okay, so this is the BST. Let us assume this is the BST, and if my target that I'm finding is like what is the smallest node here, the smallest node is okay, let me erase this stuff. Okay, the smallest node is 6. 6. So let us assume I'm trying to find x is equal to 5. This is the target that I'm finding. So first, when I'm at this position, I see my root data is greater than 5, so I'll be going to the left. Again, I see that my root data is greater than 5, so I'll be going to the left. Again, I see my root data is greater than 5, again I go to the left. So once I come here, my root equal to null. So at this case, my temp would be -1. Okay, temp would be -1, and all these cases, my present is int min, because I did not go to the else if condition anywhere. So a maximum among these two is -1. So that I'll be returning. So that is how I have coded this. So only two things. Either it can be your root data is greater than x, or your root data is less than or equal to x. If it's greater than x, then go to the left side and check. If it's not, then your root data can also be an answer. So that is the reason, store it in present and go to the temp and work on the right side of it. Leave it to the recursion. Okay, so you'll be working on your right side and you'll be getting some answer in temp. So return the maximum among them. Temp can be -1. Temp can be -1. It might be the case like you couldn't find any value that is less than your target in the right side of your thing. Okay, in that case you'll be returning -1. In case you'll be returning -1. So maximum amount present and temp would be the present. That's it. So this is how you'll be coding it. It's very easy question. Simple recursion, just a common sense thing. Understanding BST and proceeding with the formulation and concepts of BST. So I'll just run this code for your reference. Submit it. Okay, it's being submitted. Yeah, it worked. So if there are any doubts, you can just comment on comment section. And also for your reference, all the codes in C++, Java and Python have been uploaded in the GitHub repo, and that link has been given in the description. Do check it out. Thank you for watching the video. Stay tuned.